All right. Good morning, good afternoon, good evening, depends on wherever you are. Thank you so much for joining us for the Build with AI, generative AI workshop on Google Gemini and Vertex AI virtual. I'm Bill, the GDG Cloud Seattle lead and also founder of AI Camp. We're going to host the events for today, and we're going to have the tech talks. We have the workshops. Before we get started, just want to have some quick introductions about the event and some of the agendas, housekeepings, and then we'll jump right into the tech talks. So for the Build with AI events, this is the community-led technical workshops and also hackathons by Google developers. So the events are designed to empower developers to both learn about and also apply their skills to the latest trends and product in the generative AI as offered by Google. So the events is a series of events. It's hosted both on virtual and also in around the world, in many cities around the world. Including tech talks, including the workshops, hands-on workshops, and also some of them include hackathons. So it's great events, and I'm glad today all of you guys join on the virtual versions. We see how more than 1,000 sign-ups from more than 30 countries. It's great. So great to see you all. So the event is hosted by the GDG Cloud Seattle and also in partnership with the AI Camp. So just for those who are not familiar with the AI Camp, so we are a global AI developer communities with 350,000 developers in more than 100 countries. So we are basically AI developer communities. We're hosting events and both in virtual and also in many cities around the world. So many of them probably already joined our events, either virtual or in some in-person events like in Seattle, San Francisco, New York, Boston, and also in London, Paris, and other cities around the world. So for today's agenda, we're going to have a few tech talks by Googlers and also the GDG Google developer experts. They're talking about the Gemini, talk about the Gamma, talk about the Vertex AI. And then we're going to dive right into hands-on workshop sessions, which we're going to go step by step on to finish a project. So those one is a great way to learn the generative AI technologies by working on the hands-on workshops. So we have, I'm so lucky to have speakers join us today. So we're going to, later we're going to come into their sessions. So this is for the workshop later on. So today's session, the first half is going to have 3 tech talks, and then second half going to be the workshop. So we're going to do the live support on the Slack and Discord. Please make sure to join the Slack and also Discord. If you later you have questions, have some troubles on the workshop, we're going to provide support on the Slack. So when you can scan the QR code to join, make sure you join the virtual events, that channel. We have a lot of channels over there. Make sure you join this channel so your messages can got, we can provide the support right away. So I think that's all for me, and we going to have the first speaker, Nilam. She will talk about Gemini making AI helpful for everyone. Nilam, she is Google's working on the generative AI technologies. Without further ado, let's welcome Nilam.
Hey, thanks, Bill. Good morning, everyone. Good evening. Maybe we are joining from 30 countries. So maybe good evening, good afternoon, and even good night for someone. So, I I work as a customer engineer in Google Cloud, and day to day, like my work is to find out use cases and solve with generative AI. And today, if you see this slide, what you guess from this, like how it is even related with AI? So anyone paste it in chat. We will see like how you can relate with this AI. See, in left side there is this bird is baby of Indian sparrow. This is like very local side, local bird you can find out everywhere in India. And there is right side, he is very comfortable with his mother. He's hugging his mother in that case. And specific to this is not a story, this is real life incident I have seen maybe like last month. It was very like unexpected weather happened, and too much stormy weather. And due to too much storm, this child just fly down from the nest, and he was not even able to walk. He was very like maybe 2 or 3 days, and he was not even to able to walk. And in evening when kids were playing in park, they found out this baby, and they for them it's like a toy, and they were like, oh. And then I asked like, this is baby of someone, how you can play with this? So then they thought like, oh, we have to find out his mama. Then I thought like, how you will find out? Then I just guided them, can you try out Google, how Google can help? And they were, some babies were not even aware what this baby is about. It's like a maybe like Indian sparrow, or like there is another bird baby. So what they have taken, they have taken picture of this baby, and using Google Lens, then Google Lens has given complete detail what is like this baby is about, how old is this baby looks like, and related videos there, like sounds related to this bird is YouTube videos are available. With single picture, they were able to find out, oh, this is the like baby mother can be, and this is the sound. If we play this sound, might be mother can hear that thing. And suddenly like maybe 4 or 5 minutes, mother was also looking, and mother came and find out this baby. So this is like the impact. If you see, Jen, it's like if you consider, this is like a common example you see, but how AI can help. And that is again a multi-model capabilities, like taking to picture, finding out related videos, and how it searched from that particular picture, find out related pictures that there in videos where this picture has been seen, finding out text related to that information about that, summarize so even a child can understand. That's the magic Google do with AI. And this is like the magic again, like how as a developer what magic we can see this. And as a developer, we are in similar situation just like a child. Every day we see like there is new model get released, oh, how to involve that, how I can just start try out a quick POC with that model. Is there any way? And which is best in that case? Is this model they have released like this is 13 billion, this is 70 billion? Which model to choose? My use case is not related with 70 billion. So we are also get lost like that child into that weather. And how sometimes even context is not there. Sometimes we are not even to able to identify which model to choose, where to deploy resources, and specific. Then other things comes like you have to worry about future security as well. It's nothing to do like you are working a business, it's not your individual data, it's like other user data, how you can respect that user data as well. So that's the situation every developer face. And how Google can help is like, this is our operational approach to work with generative AIs. You get production ready data, and that is again with all the compliance. Like you have data these days, like data is in bulk, whether it's like structured, maybe IoT sensor get released, push lot of data. Then you have your wearable devices, you have like your particular like maybe like images, video. And if you compare the videos, YouTube upload in 1 second 1 8 hours video that you should watch. So that's what the like frequency of this data, but to generate your model might be used with this information, but how you can quickly work with this. So our approach is like, we consider in generative AI development how you can easily integrate your unstructured, structured, semi-structured data at one go itself. And then specific to open integrated, like maybe might be your use case is specific to the security, in specific to one industry domain. Might be you want to specific focus for you is like accuracy, document translation, but there in document translation there is no scope for even 0.01% error. So as global, like Google release models globally that are used globally, so it might be not specific to that domain. But what Google can help you with this is like, it's give you a platform there you can find out all the open source most popular model in our model garden. You directly integrate, one click deployment is available, and that is again your own parameter, how you control who will be having access, what type of access you will be having. And then specific to democratizing AI, like for the public, I see like daily we use, our day starts with the like clock, calendars, and then your phone, so it's already in ecosystem. But specific to the generative AI, we have services that are mapping to the all the business personas as well. It doesn't matter, like you are business analyst, then how you can leverage generative AI in Google Cloud. We have product there, you might be not need to aware about your how to write Python code to develop that model, but if you know the SQL queries, how further you can use generative AI, we have services for that. And then again, if you are a business user, how you can manage, like I am CEO of a company, how you can generative AI can be helpful in my day to day. So we have workspace there that have AI enabled in generative AI model enabled in that. There you don't have to even worry about how it's generating even response. But there are model builders like us who think like how to even start the services. We need like to write a model development. Maybe you need infrastructure, so what, maybe like even you are just like software developer, you need ID. Do we have ID for AI as well? So we provide that managed version, if that comes with your all the enterprise compliance stuff, or maybe like you can go with collab open source as well in that case. And then again, there are services like with generative AI, it's not like if you don't know Python then you will be out of the stream, it's not going to happen. So how Google has done is, in that case there are services where backend developer will be working on the integration. They can use their knowledge of existing how to build APIs that can be further integrated, but they can use further enhance their product feature using generative AI, because model is again a API. How easily, how intelligently you integrate that integration, this endpoint, further enhance your use case, that is also available. So we cater every person, it doesn't matter what technical skills you have, you will be able to use generative AI. And specific to the like what is like our approach in this, so we call it hyper computer AI architecture, we call it. And this is like a down, we have product that are available to, like we have around 9 product that are used by 1 billion people in the as of now, and all have AI enabled in that. Whether it's like spelling correction, YouTube transcription creation, or maybe like Lens, and you are using Android, then if you are using Pixel, then it's like Magic Eraser is available with you. And then specific to the like word class, we have model that is like there are different variation in that, based on your use case can you can choose and pick up that. And then we have open source as well. If you have like compliance, maybe in healthcare, maybe in government public sectors, you have compliance that you can't work on the closed models, so we have our gamma, and that is again available in different shape and size based on your use case or available infrastructure you can try out. And then specific, this is truly a differentiator. These days you want to go with any cloud provider or any data center provider, they will say no, we don't have GPU capacity, and everyone is in hurry, like we want to train this a billion and trillion of parameter model, and we need 1000 GPU, 5000 GPU. And for that, this is like how you will be able to, if like GPU is like demand and supply constraint is now, but if you consider like you can go ahead with the TPU, so that is again a like specific, you can do your training job there and inferencing as well. So how Google is doing Gemini inferencing and training, this is our own hardware that is available to you as well in the cloud in any shape, just like the containers available based on your capacity, your demand, you can use, and just you will be paying for per second in that case. Then specific to the like, it's nothing to do with this infrastructure, we have the tools available as well. They are developer, like maybe like Google AI Studio, you are as a developer, you want to try out quickly the POC, and you are not like in your individual capacity, maybe you don't have access to Google Cloud, that is like Vertex AI enterprise version, how I can try out all this API. So Google AI Studio is just like the Chat GPT, you go there, create your API keys and directly use it. And then we have like specific to the like all the models available, third party models, and then specific to Gemini, like you can directly, again this is multi-model, you can upload pictures, files, and it give output in text and in some table structures as well. And then specific to the like, maybe you are working as a developer and there is particular versioning system need to be managed, you want to run that particular AI model in that browser or maybe that ID, then we have the cloud Gemini code assist, that is behind the scene Gemini only, you will be able to work in your ID, your context, and specific to the your all the compliance rule, if you are working for enterprise in that case. And then specific to the like, we have integration with like GitLab there in the CLI command itself, like you are working in the code review, or maybe like in build pipeline, you maybe you have written the ray pipeline, but in that you want to use CLI to invoke review your code, then you can directly do with the CLI as well. You can call our Vertex AI model directly as a CLI in this GitHub and other parties as well. And then specific to the like, I know like how I mentioned like Google is considering democratizing all the enterprise services as well. So that's the like one picture you should have in view whenever you try out any new services with generative AI. If you know that you know how to write Python code, TensorFlow, and all the like latest AI model framework, directly go ahead and use GPU, TPU based on your requirement. You will be able to use that from directly from cloud. But then specific to the model builders, there will be Model Garden. So Model Garden is like we have 130 plus open source model, and all the popular model, just after the announcement, you are they are easy to access in Vertex AI Model Garden. It will give you what are the infrastructure you will be required, and this is one click deployment. It's nothing to do that like there will be document you have to follow. You just choose which parameter you want to deploy, and then it give instruction what is the hardware required, in which region you want to deploy. If you want to have encryption requirement, you can directly choose like you want to go ahead with managed, customer managed, or your Google managed encryption in that case. So directly that is like available. And then you have specific like Vertex AI model, Vertex AI Studio. They're all the first party model, and these covers all the modality, maybe speech, image, text, video, and even audio. So there they are available. And how this is different from Vertex AI Model Garden is like we are binded towards SLA. That SLA can be specific to the terms and condition that we will be not using your data for training our own base LLM. Second can be like maybe you have business critical application running on that. So we have SLA bound there. Like we will be providing this endpoint availability 99.9%. Just note like Chat GPT you are using. They mention like we are out of capacity. So if you are using Vertex AI model, you will be not having that options. You can go and take Google like this is the API endpoint, and this is how I was managing. this SLA, and Google provide that service as well, that you can manage what was availability of this resource, this particular endpoint, and you can see like this availability you are not able to meet, then you can just like Google is bound to pay you back in that case. Then specific to the like maybe you have particular requirement like this is the compliance I need to follow, so we have to take like compliance, maybe HIPAA compliance, PCI DSS compliance. How we there help you, like we provide our compliance certificate, then you can show to your auditor in that case. Then other services like maybe a model builder you will be using, how the prompt evaluation you can do, how you can define the surveying and manage training and inferencing pipeline you can create. And then tuning as well, you can do the RLHF training as well, and even fine tuning of that base LLM model is also there. Then specific, the major part is like evaluation. If you go, there are two models, you will try out prompt maybe 5 or 10, but at production scale, how you will try out which model is best. Which model is best, maybe your use case is more towards the accuracy, where use case maybe towards more like if it's customer facing, it's bias detection, and another can be more towards like any specific like its factuality, how truth is this information and how this model has generated. So we provide that evaluation. Sudden like in future it will be more towards like you can with Google search you can see like how factual, how true your information is, that and that API is available in beta to every developer. Then we have like pipeline and then monitoring, again the same metrics that for your ML models you have. You can have model monitoring available, what is the drift happening if you are fine tuning that, so that is also supported. Top of that we have Vertex AI agent builder, so that is like backend or front end developer. They might be having use case like we are working on the onboarding part of our application and their user upload data in unstructured format, how we quickly can digitize that thing. Or maybe use case maybe like there is lot of internal data available and you want to increase productivity for your internal resources. So you want to build a search, and that search should not have capability like keyword search, it should be semantic in that case, and it should be process your multimodal input as well. So is that out of the box available? Yes. So with Vertex AI agent builder you can build search agent, you can build your generative conversational agent, and then based on like maybe because that is like LLM model is basic behavior is like they hallucinate a lot. It's like if you consider their factuality information, but specific to the like Vertex AI agent builder you can ground with them with the like your own data, and that is like all the agents can use. Maybe like you are building a chat agent, there you can use your data as a data store and ground that information and instruct, write all the instruction you can write in natural language how to process. Maybe you are creating a internal search, and for search you want to create a, instead of just providing the document link, you want to create a short summary about that search result, you can do that. And same search experience that you see like if you do Google search, then you can ask follow-up questions, it's available in some regions. uh, there you can ask specific follow-up question related to that query as well. So that same search experience you can build on your own data, and you can define like how instruction you, if might be like you are writing that application for that search for support agent in that case, maybe for front end office staff. So there they might be like not able to understand this technical jargon, so you want to make sure that this support agent or the chat agent is able to explain this in layman that is layman language that everyone can, even in non-technical people can understand. How you can do that? So just write a prompt in your natural your search agent, you have to answer this way and step by step, and your work is done. Then specific to the like your top solution, these are like we have industry solution. So Google is heavily invested into research. We have MedPalm, SecPalm that are domain specific LLM, and there are like other APIs you want to automate contact centers, So it's completely end to end, since you are onboarding of like agent to on the call to the like real times like real time analysis of that call, how that particular call is going. And then for future as well, you can generate all this call as a FAQ to further enhance your productivity of your front end staff. And then specific for the like you can build your own agent using the Vertex API. If you have further like maybe you want to train domain specific, might be like uh, you are a retail company, and there you want to make sure like a assistant should be specific to our product, our brand, and whatever the data available. Then you can just write all these instructions and specific to train it to more towards your domain. You will be able to do, like even business user can do that. It's not like any language programming language is required. These are like most of the model garden you will be able to see. And just to update, like from Hugging Face you can directly deploy, like there is latest model release and you just quickly want to try out, just right click, deployment is available there. And then specific for image gen, you can create right images from text. You can edit image, like there is maybe from background, there is use cases like I am a car reseller and I want to remove background because people upload with any background the picture. And at that scale, how can I leverage generative AI? You can image gen and just use that API. And then specific to the like Gemini, we have two models available, Gemini 1.0 and 1.5. And then we have normal text as well. So and we have multimodal as a pro. So if you see the model having Gemini 1.0 or 1.5 pro, so that is our multimodal that take input as text, audio, video, and images, and you can solve all the complex use case just like that story in your day-to-day life as well. Then specific for the this all these services, that is again prompt designing, evaluate, and specific for evaluation, you have maybe system evaluation you want to do, or model evaluation you want to do. And then output evaluation, you want to just verify that output. These type of evaluation are available. And then specific to the like you will be able to compare, this is ground truth and where your output particular output from the LLM lie. And then specific for the your agent, you can orchestrate. These are like integration as a SDK you can integrate. With ground search you can have like you can built in RAG as well. And other option is like you ground with your own data. And we have connectors available, maybe you are using Jira, then you can directly use that as a connector. You are using having like Elasticsearch, you can use that as a connector. And you can call like different you can make extension out of all this AI models. And then specific to the function calling, that is like you you want to give answer in a specific format, maybe specific to your like this is my transactional database, but I don't directly want to integrate my LLM with my transactional database. I need to integrate in between something, so their function you can write and call that as an endpoint where this your endpoint is hosted. Might be you want to just write a business logic, maybe some information get uploaded and you just take that information and maybe write some code out of that processing done on the fly, event driven. Then that function also you can call. And then specific for the document processors, so if you consider about agent, so we have different type of parser available. You can have OCR, digital parser, and latest announcement like 2 days back was document layout processor. That is like if your PDF or any unstructured document that have complex table charts and you want to process that, if you implement that use case directly, you have to implement embedding, chunking and embedding, and then again multimodal embedding you have to use. But with layout parser, you can directly go ahead, just upload, and you will be able to query that. Then specific for the ranking and retrieval, we have our matching engine that you can directly use, and it support ranking as well. You can define like maybe LLM gives lot in your search query, it gives lot of answers, but how user will select like this is the right answer. So therefore in ranking you can decide on what percentage score. So for each the output it will give the confidence score. This is the confidence for particular this document, this information in this document. Then based on that you will be able to see that information and user can choose, and you can decide on you want to display just top 3 or top 2 based on your particular application. It's like in mobile, then you can't flood all this information in small screen. So that will be very helpful to make your user experience better as well. And then specific for all the other grounding option I mentioned, like you can use Google search your data that is available in API. And then we have RAG orchestration and RAG validation and analysis as well. And with that, let me switch to demo part. So in specific to demo part, if you have access to Google Cloud, then you will be able to see Vertex AI Studio. There you can see you have different modality, maybe like language, vision, speech, and they have given sample use cases how you can quickly take like maybe a table, how you can just get the information out of that. Maybe like your use cases like maybe unstructured information is there, and maybe like there is video and you want quickly to summarize that video. So how you can do so, and it support like multiple input, and like you can submit even long videos as well. And then you will be able to create like transcription of that video as well. And there is like no noise, then specific use case of marketing, like based on that video playing you want to place your particular ads. So there might be like get idea about this and then try out where you want to place that video. And then use cases like specific to document summarization, audio transcription. So you can just directly upload, and all the like even if you try out Google Studio, that support directly from your Google Drive as well. And then specific to the like there are built-in solutions as well. You can directly go ahead and try out code samples. There are bunch of code samples available specific for your use case, how that work. Maybe like you want to see how that particular SDK works for this type of agent. Maybe you want to integrate LLM agent, so you can directly go ahead this as a notebook, and you will be able to directly use in your business use cases. That's from my side. Now call to you, like find out the problem just a child was facing and see that from the maybe your company or individual perspective, and solve with Gemini. That is like that we call it era of Gemini today. Thank you.
All right, thank you so much, Nilam, for the great presentations. Let's see if we have any questions. I think one of the questions I see in the comments about is it available through the APIs?
Which model is accessible through an API?
Yeah, I guess this might need to be more specified which ones, but I do know like Gemini have some API available for the.
Yeah, all these are LLM models are available as a API. If you go there, and let me try to show you some prompt, like this is just a graph. And if you go there it will be available as a API as well. It will show you like how you can integrate. If its screen is visible, you will be able to see get code. Then it provide how to integrate in Python, how to integrate in Node.js, Java, and then if you want to use the as a API curl, how you can use that as curl API as well, curl request as well. So directly you will be able to see. And this is the version, like if you talk about version, they mention it Gemini 1.5 Pro, And then you will be able to find out like this. If you have your own account as well, there as well you will be able to see these preview models, and they will mention about dates as well. Like if you see 514, so this is like our model that will be announcement will be done in the 15, and then you see the 9, so whatever announcement we have done on the our next, so these are available, all the features you will be able to try out from this. And same for the language and all this, all the models are available as a API as well. Even Vertex search API that I was telling, you can have Google search experience, that is also available as a API. You can go and use like however you want to use.
Great, thanks. I think we have one more questions. How do you find the cost of each of these service? Is it per API request when everything
Yeah.
is set up and running?
Yes. So it is like if you see, it is showing 271 tokens, and our pricing is per character, and that will include specific to the like if you are using Gemini 1.5 Pro, then for each the input, different tokens will get counted, and then you are charged for the number of tokens in that case. So that is the cost, and there will be cost for the output, maybe like number of tokens you want to generate in output. So that will be again like maybe 1,000 characters or short of that. Pricing is also available, you can verify, but that's how pricing work: input token and then output token. So this is available through Vertex AI. If you go to Google Cloud Project, and if you are using your individual account, let me show that. Just hold on. So if you want to try out with your Gmail ID and not with the Office, you don't have access. So this is aistudioGoogle.com, and you can search it out with Maker Suite. You will be able to see the same look and feel that is available in Vertex AI. And same, you can try out different models here. You have capability to use the tuning capabilities as well. And then again, you can, if that is POC is done, you can deploy it same into Vertex. You can directly move this existing project into your particular Vertex AI project as well. And again, like the same SDK input, all the available, you can try out. And if you go ahead, you will be able to see like how you can go ahead with your Android and iOS integration, SDK integration. And input all these capabilities are directly available in Google AI Studio as well. So for quick prototype, I suggest like go ahead, don't wait for Google Cloud access to be enabled for you.
Okay, let's go with the last questions. I think we are a little bit running out of times. So let's we have the last questions.
No, it is character wise, and you want to see like if you ask like you are counting token but pricing is in character, so one character like we specific take like around 4 tokens. And then is like there is model available, API available, there you want to see like before even trying out your model, and you want to see what will be the cost estimate look like, then you can try out that API that will give number of tokens in for particular that text or whatever the input you are providing. So there before even you try out your model, you can calculate what will be the token.
All right, thank you so much. Thanks a lot for all of your questions, and thanks Nilam for the presentations. Yeah, so we're going to one more question for Nilam. Someone is asking about the slides. Are you able to share the slides later? Maybe you can share to me, and
Yeah,
I will share
sure,
to
sure.
the
I will share.
attendees
Yeah.
later. Okay, awesome, great. Well, thank you so much. We're going to move out to the next sessions. Our next session is from Nikhil. He going to talk about the Gemini models building applications. Let's welcome Nikhil.
Sure. I hope my slides are visible.
You need to share your screen. Okay, yeah, it's coming up.
Okay, cool. Uh, so I guess I
Yeah,
can get started.
yeah, you're ready to go.
Sure. So thanks everyone. First of all, good evening, good afternoon, good morning from wherever you're joining. Thanks for joining. We've got a amazing lineup of sessions. Hopefully, I should be able to add some value to this amazing lineup. Uh, my name is Nikhil. I'm an AI consultant, part of Google Cloud, and today I'll talk about how do you give your applications an AI upgrade with Google Gemini. So whatever Neelam spoke about, we'll sort of try to deep dive into certain aspects of the Gemini model family, and certain other aspects of how you can sort of access Gemini. So briefly talking about the agenda, I'll just bore you guys for a minute on evolution of AI. I think this is something that everybody knows, but I'll still go over it. Why that is important, because I'll talk about the Gemini era and why do we call it the Gemini era. Uh, Moving on, next would be accessing Gemini. I'll talk about different ways how do you access Gemini. Some of them I think Neelam has already covered. There'll be a short demo. No, this might not be a very big demo, but I'll try to sort of showcase something around Gemini 1.5 Pro to sort of give you guys a flavor of the large context window. And then yes, open for any questions in the end. So evolution of AI, I think this pretty much everybody knows. We are in 2024. We started off with predictive AI. We did a lot of regression, classification, fought our battles with uplift, precision recall, F1 scores. We moved on into generative AI in 2022. We got GPT models, we got Palm 2, we got other models, open source, closed source, etc. And then 2024, we are in the multimodal era of GenAI, where we are dealing with not only text, images, audio, video, and different multiple inputs at different types of input at a time, and sort of getting responses from these models. Very advanced models that are coming into the market. And over this course of time, I think we developed the framework also. We evolved right from the training, serving, and MLOps perspective. Now we are talking about prompt tuning, doing RAGs, and doing LLM ops on top of our applications. Where do we head next is something that only time will tell. But what we are currently talking about is the Gemini era. Now, why we call it the Gemini era is because this is basically uh, every developer, every business user, or any AI practitioner, whatever they were used to doing with Gemini, it's basically doing it efficiently and better. So you have Gemini everywhere. It is not just a family of models. It is an entire ecosystem. So that's why you would see Gemini in Workspace. You would see Gemini on Google Cloud. You would see Gemini models, and basically all the products that basically Google has, it will be powered by Gemini, because that is where we are heading. That is the future. So what is Gemini? Just quickly, talking about this state of the art Google's model, multimodal capabilities, highly advanced reasoning capabilities. It's built with highly optimized AI infrastructure, and it's obviously built with the responsible AI principles that Google has been sort of taking into consideration since the past decade. So when we talk about highly optimized, so it's obviously leveraging Google's AI optimized TPU infrastructure. And if I talk about different flavors of Gemini that are available, you have Gemini 1.0 Ultra, which is the most advanced and the largest model probably of the entire family. It's very specific for highly complex tasks. Then we have Gemini 1.5 Pro. It's probably the best model for handling tasks for a very large context window, up to 1 billion tokens. I have a specific slide on this. I'll talk about more on this. Then the best and the most used model is Gemini 1.0 Pro. This is basically used for all the applications that we've been talking about, and what you couldn't see in the industry happening. And then we have Gemini Nano. This is something that still it's in under production, and it's mostly an efficient model for on-device tasks. Something that I don't have on the slide is Gemma. I think Neelam spoke about that. We have those open source models, 2 billion and 7 billion parameter models. You can access it via Kaggle or the Model Garden or Hugging Face. So talking about accessing Gemini, now there are 4 ways in which you can access the Gemini model family. So the first 2, I think Neelam has already showcased this. One is the Google AI Studio, earlier known as Maker Suite. So that is the fastest way to sort of get started building with Gemini. All you need is a free Gmail account, and you can start prototyping with an API key. And once you are comfortable with your prototype and you want to move into a production setting, you want to scale your GenAI application, that is where we would recommend going into Vertex AI, which is a fully managed AI platform on Google Cloud. So there you have an enterprise-ready AI platform. You have all the data privacy and security in place, be it VPC or CMAC keys or anything related to data security. And then you get some more advanced tools, which I'll again talk about in terms of customizing your models or augmenting your models with external data. So this is how you basically, these are the first 2 ways in which you would access Gemini. So talking about Google AI Studio, I think Neelam already showed all of you a demo. You can search for this on Google, and you can just get started with it. Highly recommended is a link. This is a Google Gemini cookbook. So if you are a Node.js developer or JavaScript or Python, we have a cookbook that sort of talks about these amazing recipes of GenAI applications that you can get started and start building something awesome on your own. Talking about the second most way to sort of use Gemini is Vertex AI. As I mentioned, this is fully managed AI platform. I think Neelam sort of showed you the building blocks of this, but I'll just quickly run through it. It's based on, it's built on top of our GPU and TPU cloud infrastructure powered by our Google Data Cloud Centers. You have a model garden, you have a model builder, you have agent builder, and you have something called as AI solutions. They're very specific for use cases, and they sort of cater to specific industries. For example, contact center AI that we have for any telecom or any customer service related customers or clients. And to talk about model garden, I think there are more than 130 plus models that are being added here. Both first party as well as open source. We got Cloud 3 models, Haiku, Sonnet, and Opus that were launched last month. We have Llama 2, and obviously there are a lot of new models will keep coming here. We have a strong collaboration with Hugging Face and Kaggle. That's where you can access model like Gemma via the model garden. And what Model Garden gives you is the flexibility to sort of use open source as well as closed source models together in your AI application, and sort of orchestrate them in a very harmonious way. And you can build a very powerful application using these GenAI models. So Gemini foundational models are there. Some older Google foundational models like Palm 2, our image generation models, our text speech to text model Chirp is there. Code generation, code completion model Cody is there, and then you have our embeddings model, which is Gecko. And then there are specific task related model which you can sort of explore in the model garden. Talking about Gemini, because this is what I'm supposed to talk about. So the first one that I will talk about is the Gemini Pro Vision. So this is obviously a multimodal endpoint that sort of takes in any image or a video and generates a text output. So we've seen a lot of use cases, be it image, text to extracting JSON from output, or sort of doing a video Q&A on a video, or sort of describing an image or a video content, or if, for example, there is a use case wherein you have a security footage and you want to analyze the footage and sort of understand where a specific security incident would have happened. That is where Gemini Pro Vision would sort of definitely help you out. There is a link on how to design these multimodal prompts. It's part of the documentation, so definitely something that I would highly recommend. Moving on to Gemini 1.5 Pro. Now, this is the most talked about model, probably the biggest context window that we have, 1 million tokens. Obviously, couple of things I would talk about here is it's built using the mixture of expert architecture, which basically doesn't pass your tokens via dense network. It basically divides the tokens and passes it via different sub networks. So it's sort of a divide and conquer kind of thing, which sort of enables efficient training and sort of efficient inference also. So definitely that is definitely helping out these models in terms of latency and inference times. It has a 1 million token limit, better understanding and reasoning capabilities. The image that I have would have seen in the marketing videos, that was the Sherlock movie, 44-minute movie that was uploaded, and it was asked that where did this particular scene happen, with just a sketch of a drawing, and Gemini 1.5 Pro exactly analyzed the video and said that it happened at a particular time code, and sort of gave that time code. So a lot of people are calling this as the rack killer, because you don't have to do all the chunking and pre-processing the documents. You can just upload the documents all together. One interesting use case I can talk about is one of our customers, an e-commerce company. What they did with Gemini 1.5 Pro is they ingested 3 years worth of financial reports into the models, which were each 100 pages. And what they asked is the model to sort of analyze it. And the model not only analyzed these 3 huge PDFs, but it also sort of gave insights on how the macroeconomic conditions help the company grow over the 3-year period. So that was amazing. Not only have external knowledge, but the pre-trained knowledge of the model sort of helped get great insights. This is something that we recently published. It's not a model available right now, but it's called Med Gemini. It's specifically for multimodal capabilities with regards to understanding medical data, or it has been optimized for medical use via fine tuning with 2D and 3D radiology and dermatology and all the genomic data. And also you can use any kind of medical data, put it into Med Gemini, and it will sort of do any sort of applications use case that you would have, be it classification or report generation, or any risk prediction for genes and all. So something definitely to watch out for. Some of the capabilities from the Gemini perspective, function calling. We have very advanced function calling in Gemini. Function calling, for those who don't know, it's basically an inbuilt feature that Gemini has that helps you sort of transform natural language into structured data, and you can get it back. So basically, if you have a model and you have multiple functions written, it doesn't call the functions. It basically delegates the task and basically gets the right information from your delegated functions. So it's an amazing tool. You can sort of extract structured data and the right piece of data from a haystack. So definitely a good feature and a very useful feature that we've seen. Talking about, so we spoke about different models of Gemini that are there, but how do you choose the right model for your use case? This is, I won't go through this in detail. This probably, if you would have attended the Google Cloud Next sessions, this was something that was showcased. So if you have a use case, depending on the modality and depending on how much long is your input or input context is, you can decide which specific model is suited for you, be it images or code, or it could be just natural language generation, etc. So This is a very nice flow chart that sort of guides you in terms of choosing the right model for your use case. So talking about models and choosing the right model, now we talk about how do I customize it. So starting with prompt design, this I think prompt engineering everyone is doing with different type of models. But then what is the next level is basically doing supervised tuning on top of that. So for Gemini, we have Gemini 1.0 Pro right now for supervised tuning. The other models are not yet available. And then something that will come soon for Gemini would be RLHF, which is reinforcement learning human feedback, basically training your model based on human feedback. And then basically model destination, which is basically you have a teacher model and you have a student model. So you want to, train a small size model using this large size model and basically take the learnings and sort of, you reduce your inference time and, you generate better responses for your specific use case. And then in terms of evaluation, it could be metric based, or if you want to do it in an automated way, we have something called as auto side by side. It basically helps you battle out two different models for your question answer generate use case or summarization, and it basically helps you evaluate two different models and help you choose the best one. So that was on the customization part. On the augmentation part, obviously you have RAG. You can definitely use these models for them. But apart from this, certain other features that I spoke about, like function calling, you have grounding. We have a feature enabled as grounding. So when you go to the model garden and you sort of start playing around with Gemini, you have an option to sort of use a grounding option there enabled. Which sort of helps in factuality and helps in reducing hallucinations. And then you have also something that is coming up in preview right now is extension, which is basically if you want your model to sort of access some third-party applications, or you want your model to sort of run your code. So there could be like a Python code interpreter via an API available for your model. So you don't have to use Cody. You can use Gemini along with this code interpreter extension, and you can sort of analyze code and sort of generate code or develop code using extensions. I spoke about model builder, model garden. Now something on the agent builder. I think I'll just briefly touch upon this. I think Neelam already spoke about this. So in model builder, we have two different variants. One is the search one. So what we have is basically Vertex AI search. Here, what you do is basically you do nothing with regards to the usual RAG. You don't do any parsing, chunking. All you do is basically upload your data in a GCS bucket or any drive, or we have connectors there also, like if you have your files in Jira or Confluence. And then Vertex AI search would sort of take that entire data and sort of do the parsing, chunking, embedding, and all those sort of things that you do in a usual RAG. And the final output is basically powered by Gemini. So the summarization and the conversation will be taken care by Gemini. So it's basically an out-of-box solution which gives a business user who doesn't want to develop a very low-code, no-code kind of environment, and you can sort of build a search engine by just few clicks of button. The second one is basically the conversation part. This is the agent builder's conversation capabilities. So let's say if you have a product page like this, you can easily build a chatbot that can sort of answer queries based on your product page. So what do we call this as is Dialogflow CX, and there are other names like Conversation Agent Builder or Infobot. And basically, this is again a low-code, no-code solution for anyone who doesn't want to sort of code and basically, build a chatbot and basically integrate it as part of their application or website in just matter of clicks. And well, if you sort of run out of ideas on how you can use GenAI, then we recently published a blog with over 100 real-world use cases that we've already delivered with our clients. But there is a fifth way to sort of access Gemini, and that is Gemini for Workspace. Earlier, it was called Duet AI. Now what we've done, as I mentioned, it's Gemini ecosystem. So everything is under Gemini. So you have Gemini for Google Cloud and Gemini for Workspace. So anything that you use like Gmail, chat, Sheets, Meet, everything is powered by Gemini now. So that functionality that you use in Gmail, which is help me write an email, that is powered by Gemini models now. And then similarly, we have for Gemini for Google Cloud. So what you can see, it's now starting to penetrate each of the domains of application development. So if you are basically using Gemini for code completion or code understanding, you have Gemini Code Assist. Or if, for example, you have a complex application running on cloud and you want to analyze the logs, cloud logs, and find discrepancies, or find any optimization opportunities, you can use Gemini to sort of ask in plain natural language that how do I do this, how do I do that, and it sort of helps you guide through the entire life cycle. So that was mostly the content that I had. For the demo, I'll just quickly showcase a small thing. uh, yeah. So what I have is basically uh, I'll showcase the function, the capability of Gemini 1.5 Pro. So this is basically, as Neelam showed, this is the Vertex AI console where I have the Vertex AI GenAI Studio. Now what I do is basically I go to multimodal. I select the prompt design. You can do the multi-turn prompt as well if you want to do test like a chat, multi-turn chat kind of prototype. And what I do is basically I'll sort of upload two PDFs. So a bit about these PDFs. So one, there these are two research papers, not long. It's like just 20 pages each. One is a research published by Google. Another one is, I think, it's Megalodon. So it was similar paper. Both the papers are similar, talking about infinite context. So I'll upload both the papers, and I'll just put a prompt. Give me 10 major differences between the two research papers, and I'll just submit. Uh, so you would see that Gemini would sort of read this both the research PDFs, analyze the content, and based on the prompt that I have, it will sort of generate the output. So it sort of gave me, like in a streaming format, uh, like the 10 major differences. What is the core idea? uh, the Google's paper talks about infinite attention, uh, some differences on normalization, uh, parallelism, model scale, uh, yeah, focus, etc. So it nicely gave me a nice formatted output, comparing two big PDFs. And that's like just a small piece of how you can sort of use these large context window models like Gemini 1.5. So I think that's from my end. I think mostly I have covered. So yeah, if there are any questions, feel free to. Uh, yeah, Bill, am I audible?
Hello. Can you hear me?
Yeah, I can hear you.
Okay, yeah. So there are a couple there are one questions about is 1 million token limit available for Gemini 1.5?
Yeah, it's definitely available. It's in Gemini 1.5 Pro does have the 1 million token limit available. It's right now in preview mode, so you can access it via the Google Cloud console.
I go through the questions. Oh, is there another one?
Yeah. Is distilling step by step the same as self-consistent? I wouldn't say it's the same. Distillation is more of, you have a teacher model, a very large size model, and you have a small model, and you sort of, I mean, there are multiple ways to do it. You can check the documentation. We have a very detailed documentation. There are different types of distillation that you can do. One specific type I can talk about is basically you sort of try to mimic the output that the teacher model would sort of give, and sort of use the same parameters, and sort of train your student model, which could be a very small size model. Self consistency with chain of thought goes into a different kind of nuance, but I wouldn't say they are one and the same. Does Gemini or Vertex AI let a user modify the parameters? So I am assuming when you're talking about parameters, these are parameters with regards to temperature, top K, top P, etc. So yes, those you can access and modify via the UI, or when you're calling via the API, you can modify those parameters. If you're talking about parameters with regards to the model parameters, no, you cannot. You can fine tune the models and basically, do sort of a parameter efficient kind of training, or sort of a adapter tuning kind of thing, where you sort of add an additional layer of parameters on top of the model, and the model will start sort of behaving in that way based on your training data. Sure, I will share the slides with Bill, and probably the links are there in the slides.
Let's go with the last question, if any. Okay, it's coming up.
Can you talk about IP security with respect to uploading documents to Google for analysis by Gemini? So I think Neelam also highlighted this. So whenever you're using, let's say, Gemini models via Vertex AI on Google Cloud Platform, so the project is basically part of your tenancy, and any data that you sort of use as part of the model, uh, Google does not use the data for training further. Once the project is deleted or destroyed, the data is destroyed, the model forgets everything. So it's not being used for any analysis. So you can feel free to use it, and sort of the IP will sort of obviously be protected. Any data that we use for training Gemini model family, it's proprietary. It's being sourced using different sort of legal nuances, taking into consideration legal nuances. So yeah, the customer's data is customer's data. You can use the model via the API, or locally hosted model in Google Cloud Platform. So your IP, your data security is there with you.
Great, thank you so much. Thanks everyone for the great questions and the presentation from Nikhil. You're going to later you can share the links and the your slides. I can share to the attendees. if you later on, if you have time, I know it's probably a little bit late in India over there. If you have some time, I think there's some additional questions on the YouTube, so you can answer it in the chat.
Sure, thanks.
All right, thank you. All right, so let's move on to our next speaker, Rambiba. He will talk about, actually he's going to do a walkthrough on the Gemini and Gamer on cloud, and both on the cloud and on device. He is the Google developer expert in machine learning and AI. I will let him to introduce himself. Let's welcome Rambiba.
Thank you, Bill, for introducing me. And hi, everyone. Let me share my slides. Okay. Okay. So I'm guessing my slide is visible, and I have two built with AI. Okay, it's a little bit weird. Hi everyone, today I'm gonna explain a little bit on Gemini and Gemma. I think Nikhil has touched on a lot of these things already. So I'm gonna touch a little bit on the other parts. For example, what are the things which you right now have available in Google Cloud Platform that you have already seen, but some of the things what you can do with it. And also we have like two parts of this talk, which is one, I'm gonna concentrate a little bit on Gemini and then on Gemma, which is the open source model, and some of the tooling part of the like what you can do. So this talk will go mostly what you can do, a little bit of demo and share the resources. And then we have a lab later, where we can go hands-on exactly how you build those devices. Okay, so a little bit about myself. I'm Rabimbo. I'm a Google developer expert in AI ML. I'm also a Cloud Champions Innovator and Cloud Research Innovator with Google. I'm a PhD student, so I am studying, and this is kind of also my research. So starting with Gemini. Okay. So this is supposed to be that demo which Nikhil just talked about, that, okay, you upload a Sherlock movie and Gemini can kind of like explain what's happening, just the like a clip, and it can actually go through it. This was a video which was supposed to go through that. And I thought, since he has already explained about it, let's actually look at, if you want something like this to happen, what you will do. So we'll immediately jump off to a demo. So let me share my different screen, which will be this. Is my screen visible? I hope it is. Yes. Can I get a comment or something if my screen is visible? Like the collab? Okay, nice. So let's see what we have to do something like that. I will explain the steps later, but since this takes time, let me just run it. So these couple of steps, I'm just initializing Google's generative AI library from PyPy and adding my Google API key here. Then I'm downloading this file. This is the Sherlock Junior 10 minutes video, which is supposed to be in that demo. So I'm just running it directly. I'm just doing that. And then I'm going to download and extract the images frame by frame, 1 frame per second. So this is different from what Nikhil was showing in his last demo in GCP. That works a little bit different way. We'll see how it like what is the difference. Anyway, so since this is extracting frames 1 frame per second, we will see here after some time. And then we want to get timestamps to see what's happening. Then we want to see the list of files. And then we will work here. Until then, let me go back to the previous slide. Okay, so while that is happening,
This is a demo of
let's look at some of the things we can do with Gemini right now. As you can see, Gemini is a multimodal model, and it can work on images, video, text, and Gemini 1.5 can also work in audio right now. So these are the things which you can already see if you log into your Google Cloud platform. You will have access to 1.0. Some of you, if you have gone into through a waitlist, or if you eventually go through a waitlist, you will also have access to Gemini 1.5 and Ultra, but that's kind of like a case by case basis. Most of the things we are going to talk about today, almost all of the things we are going to talk about today, you can do already with Gemini Pro 1.0. Let's go back to our collab, see it's getting uploaded. So these are the frames which we extracted, and it's getting uploaded. Once it's done, so we have uploaded 10 files. I want to see that if all those are there, they are there. Now we ask it to describe the video. Okay. Okay. So as you can see, the prompt I have given is describe the video in detail and also describe the plot. And the model I'm asking it to work on is the 1.5 Pro. Now, when I run it, it's doing the request here, and okay, this is what we got. The video is a black and white silent film. The first scene shows two men walking on the dirt road in a residential area. There are several houses and cars in the background. The two men walk past a train car on railroad track. The background, there are all dedics. One of the men tries to jump into train car but is unsuccessful. So this is if you use Gemini 1.5, this is how you can use it, and it can tell you, it can understand the video, what's happening and what's happening there. Then we just delete the files and we go back to our tab. So that's the power of like a huge context window. We were able to send and you can actually send a much bigger file. For the demo, I intentionally did it very small. So you can send these, and you can actually have understanding on that. So going back to Gemini 1.5. So Gemini 1.5 is a mid-size multimodal model, the Pro model, and it's a mixture of experts model that works in a little different way than our models. So while a traditional transformer function acts as a one large neural network, mixture of expert models are divided into smaller expert neural networks. Uh, so 1.5 Pro maintains high level of performance even as its context window increases. So why context window is important? So imagine if you have a conversation with it, which you have done pretty, I would say early. By early means after that you have a long other part of conversation or long other documents sent through it. It still should be able to remember the very first or the very initial part of it. So this is called kind of like a needle in a haystack. So you give it a lot of information and you try to get answer very specific to one information which was part of it in a very beginning or any part of that. So a big context window helps immensely with it. So with Gemini 1.4, almost 99% of the tasks, the embedded text, these blocks, you will be able to get that back. So 1.5 Pro can process a vast amount of information in one go, including a 1 hour video, 11 hours of audio, and code bases with almost like 30,000 lines of code, or maybe like 700,000 words. What it means is that you can literally pass multiple GitHub repositories of code, lot of files, and ask it to code based on context of all of those files, not based on what it already knows, not based on only one part of the file. So it has bigger understanding of what libraries are getting used, what are the different associations between them. So let's look at what you can do with these in Vertex AI. So right now in Vertex AI, you have all these models available, which is there are different choices. These are kind of like the 6 examples of models. These include text, dialogue, code generation, code completion, image generation, embedding for downstream machine learning tasks. And beyond the choice, you have also built-in safety and governance, access to the best of state-of-the-art models, which is not necessarily Google's. For example, all the Hugging Face models, Mistrals, Claude's, Meta's open source models, you can have access to all of them through Model Garden. Now let's talk a little bit about Gemma and why we might want to even consider Gemma, or why that's important for us. So Gemma is Google's family of state-of-the-art models built from the very same technology or research which has been gone into building Gemini, but these are all open source. Why? So let's address the open source versus open model in this slide. So Gemma is open model built for responsible AI development from the same research that used to create Gemini models, meaning the weights are freely accessible. So anybody, if you're a researcher or if you just want to play with change certain things which are not available with commercial APIs, you can do that because you can have weights, you can do much other things with this, apart from just fine tuning. Why we won't say exactly open source, specific terms of use applies to that. Gemma has something called Gemma license, so you can use them freely. Users can even create and publish modified version of it. However, the terms of use prohibits harmful application, ensuring responsible AI development. So that's one of the tidbits you have to be careful about. Now, Gemma models, there are 2 models available right now. Gemma models has been trained up to 6 trillion tokens of text using very similar architecture, data, and training recipes as Gemini model family. And the Gemma model architecture based on the transformers decoder with improvements such as multi-query attention. These models, at least until IO, these models are not multimodal and multilingual and best used for language tasks, specifically, for example, question answering and summarization. You will be able to find open source models which have been trained, so which have been fine-tuned on different data on Gemma, which are able to do even the specific Gemma without any change. It can unofficially talk in different languages, but that's not something recommended. I can actually show that. So these models achieve strong generalist capabilities in text domains, and the reasoning skills also come with the skill. There are 2 specific models available. So one is the 7 billion parameter model, which is more efficient for deploying and development on GPU and TPU. And then there is a 2 billion parameter model, which can literally run in your mobile devices right now. We will have a demo on that. So this is mostly suitable for running in CPU. So some of the benchmarks, you can see the link on the bottom. That's where the technical report is published. So as you can see, language understanding and generation performance of the 7 billion model across different categories compared with similar sized open models. And you can see this performs pretty well compared to different similar sized and sometimes even bigger sized models. I can see a couple of comments that it's small and blurry in the screen. Bill, can you see the slide properly?
Yeah, I think it's fine. Just the coding part, you probably need to like room in.
Okay, next time I'll just make it bigger.
Fine.
Okay. So how does it fit in the model ecosystem? So these are separate model families, and you should look at for your use case. So for example, Gemini is Google's most capable AI models, and you should use it for mostly production offerings. If you want something already pre-built and have little tinkering use case for you, or if you want to fine tune it and if that fits your use case. Gemma is for more advanced usage, for example, for doing it as a mm, like research task, or if you want to have it in a use case where Gemini might not be fit or on device. So there, Gemma actually shines for your use case. Now, both of them, you can actually don't have to work in your own machine. Both of them works completely fine in Vertex AI as well as Google Containerized Services. So you can just put them in GKE and you can build your own custom models, like custom use cases with that. Now, this is mostly for developer experience walkthrough, what you can do with it. So Gemma and Google's ecosystem is that you can actually use everything we will be talking about today in GCP right now with very little friction. Gemma is available with all the popular frameworks, and users can easily do inference on fine-tuning using Keras multi-backend feature or natively in JAX or PyTorch. And also, some of you might be familiar with Llama CPP, like an open source project where if you have a model, any of the open source models in a specific GGML format, you can just do inference with it, just kind of plug and play. You can do that with Gemma as well. Gemma already comes with a GGML model, but the Google team has come up with a similar Gemma.cpp, which is a very optimized inference engine written in C++, and you can actually use it as an inference engine directly right now, and it will also run all the Gemma models completely fine. Now, if you look at the Gemma and Google AI ecosystem, this is a just screenshot from like a Google Colab, which I just showed, and this is how it works. I thought the previous example was not very clear, so we'll go through that, some like a new example later. Now, let's see what we can do with Gemma on Vertex AI. So there are multiple ways you can have access to that. So for example, if you go to Hugging Face, there is a Gemma 7-way model. And if you click on deploy, you will have something where it shows deploy on Google Cloud Platform. It will directly redirect it to Vertex Model Garden in Gemma deployment page. So if you go to Kaggle, if you're a Kaggle master or you're familiar with Kaggle's interface, you can go to Kaggle and you can just click on Open in Vertex and it will redirect to Vertex Model Garden Gamma page. So this is how it looks like without signing in GCP. So you will have this page where you have deploy, notebook, and fine-tuning pipeline. All of them will ask you eventually to log in. So this is literally how you will use. You will say that, okay, I want to sign in, and you will be deployed. And if you want to deploy it in your own container services, so this is how you can deploy it in Google Kubernetes Engine. So here you have the whole Kubernetes engine, how it was before, but now you can add, so the AI ecosystem, the model garden allows you very easily to have this component where you can train, inference, or even you can do fine tuning. So if you want to deploy it, so from model garden, what you saw in the previous talk, you can just go into that deploy and it automatically gives you a page that, okay, it provides you Google Kubernetes Engine as a target. And you have specific configurations which are already there for you. And you can also have different ways of employing it. For example, it will recommend Hugging Face as TGI. If user is coming from Hugging Face, it will go for the VLLM default if you're not coming from Hugging Face. So from Model Garden, you can also directly go to Kubernetes Engine notebook, so it will directly open it with minimal friction. So you can use this not only with GPU, you can also use it with Google's Tensor Processing Unit, which will vastly make your fine tuning or text generation process faster. These are all optimized right now and available for most of the popular frameworks available. So PyTorch, JAX across GPUs and TPUs. As you can see on the right, so you have two options, so either in TPU or in GPU. So when I said the VLLM, the Hugging Face TGI, these are all GPU-based frameworks, so these are all available in the GPU part. Google has also partnered with NVIDIA, so Tensor RT LLM is also available within GPU. So these are kind of the offerings you will be able to use already. So VLLM is highly optimized for serving LLMs, and this is hugely used by open source community, so you have access to that. Hugging Face text generation interface is another one, and then NVIDIA's highly optimized TensorRT toolkit. So these all are immediately available, and you don't have to go for any other plumbing to actually enable these to Google Kubernetes Engine. So this is how the whole family looks like. So in cloud, you have the tools and libraries, which enables you to work with these frameworks. And then you have these frameworks. And then you have the GKey, which takes care of the infrastructure part. Now some of the Gamma resources. Now let me share this tab instead, and let me make it bigger. So is this visible now properly? Can I get just a thumbs up or something? Yes. Okay. So this is kind of a demo what we want to do. What exactly you saw in the previous talk, that okay, if you just put two PDFs in GCP, that was using just normal UI, and you ask questions on the PDF. I wanted to see that, okay, if we want to do the same thing in just programmatic way, what we can do with that. So this is what we are going to do. So I have a Google Colab archive reader, and I go through the same steps. Yes, of course, it's not authored by Google. And these are the basic initial building blocks. I install the generative AI library. I initialize that. And I install some PDF processing tools. We use popular utils. You can use anything you want. Now, this is working in a little bit different way than how the GCP demo was working. We will go through what is different. So now I want to download and process a PDF. So this is a PDF in archive. This is something of my own. So I just point towards it, and yes, it downloaded extracts page. So it downloaded everything. I want to extract page 149. I think that was for a different one. Let me see which one was this. Yes, okay. So why page 1 to 9? Because most of the research papers will have things like references and everything. If we want to ask questions on it, those are not the things we need to, like we want to even pass to an LLM. So I just want to pass the actual texts, which will still have some references, but we're fine with it. So I just extract page 1 to 9, and then we extract those as JPEG images, and I want to see the output. So these are the image outputs I got. And I want to see if I extracted the right thing. So we'll try to see, and okay. Yes, of course, because, okay. And okay. So this was the paper, and yes, we want to see the first page. This is a JPEG image, and it got the right one. Now we also want to extract the texts from the same pages. So we go through that. This is the output. So now we have with JPEG, we also have the TXT files, and I concatenate all of them. And then we assemble all the files into a prompt, and we upload them using the API. So here we are using the GenAI upload files to upload the images, and it's 100%. So we also load all the text, and we have to combine them. Now let's try it out. I'm trying it out with 1.5. And so first I just want to summarize it. Oh, actually I want to do more. Okay, so we want to summarize the paper and also see what are the contributions of the paper, the strength and weakness of the paper. So this was a different paper. Once this process is done, we'll see if it is working. Okay, then I want to display what we got. Okay, so we got this is the translator of test. This is the right paper, the key aspects. These are the contributions. These are the strength, and this is the weakness. So as you can see, it was able to actually take the whole PDF, answer questions on top of that, and it was able to more or less correctly summarize the strength and the weakness. So this is how you can use your own pipeline or use just your own code to interact with the API, the model. So I'm using Gemini 1.5 model for this. Now, since we talked that we also are talking about Gemma, how we can do this same thing in Gemma. For that, I need to share my screen again. Okay, so I'm actually running a Gemma model right now. In my local machine. Let's make it bigger. Okay, so that's my client endpoint. I'm using LM Studio to run the model, and I'm running the smaller model, the 2 billion parameter model. This is running right now from my machine. And okay, so this is a multi-turn chat we have given it, and what we want to see is that, okay, if I ask it that introduce yourself, someone, so we just want to see if it works or not. So when I run it, here is the output. So it's trying to run it. Okay, so it's running pretty fine in my machine. If we look at the server logs, I can actually see the logs. So this is the server log. Let me make it bigger. Yeah. So this is what we just sent. So these are the streaming responses, and this is the model. This is the temperature. Tell me a poem. This is what I just did. This was the role. This was the assistant, and this is how we work. So as you can see, and this was the API endpoint where we tried to connect using this. Okay, so is the screen sharing not being shared? Oh, now it is. Okay. So the previous, some people can see, some people cannot. Okay, I'll very quickly go through the demo again. So what we did just right now is here I have a Gemma API running in my machine right now, and okay, let me stop this and clear this. Okay, so this is the API endpoint in my local host, and this is kind of the role and system I'm giving. You are an intelligent assistant. You always provide helpful information, and hello, introduce yourself to somebody. And I am running the Gemma 2 billion parameter model, which is pretty small model, the smaller models. And I just want to run it and chat with it. So once I run it, here I got it. So I'm language AI designed to assist with tasks and everything. So I'm saying, oh, okay, of course. So since I asked specifically for a person, it won't, so this is the responsive AI guidelines, it won't do that. But if I ask just this, so here we interact with the model, and I just showed you how it works, and I can show you the server logs we have right now. Let me open the log. Okay, so this is the server log. Let me make it a little bit bigger. Okay, so this is the can you tell me poem. We have the response, and this is the question beforehand, which I tried, and it gave me this content that no, I wouldn't be able to provide. So this is how you see this is actually running in my machine, and this is the open source model, and this is how we can kind of interact with it. So with that, I'm going to go with the resources. I see a couple of questions regarding Gemma and Gemini resources. So these are the resources. And the notebooks you just saw, and a lot of other notebooks, they are all available in this. I can just show you, including the PDF reader you just saw. So they are all available in that link I just showed. That's in GitHub. And apart from that, these are other resources which are available to you. So you have the doc page, you have the different Gemma debugging tutorials, the technical reports, and also the Google Kubernetes engine tutorials available in these links. With that, I'll probably start taking the questions. Okay, Bill, should I start with the questions?
Yes, go ahead. I already posed the question over there.
Yeah, so this is not going to be a straightforward answer. So Llama 3 and Phi 3, do you want to compare between these two or these two with Gemma or Gemini? So I'll answer for
That's a good question. I guess you can just. I think it means the two with the Gemini.
Yeah. So these two are actually very different model families. Phi, the whole family of models of Phi are from Microsoft very specifically to showcase you can have a very small model but with still much powerful capabilities. The Phi 3 is literally kind of, for example, compare that with Gemma 2B. So that's a smaller model, but what it can do, how much, can it still trade blows with a much bigger model like a 7 billion parameter models? Most of the places you will see it cannot. But Phi3 is literally the proof, or Phi2 or these smaller models that work very specific task with a very high quality data. You can still trade blows or even sometimes surpass very specific tasks in a bigger model. Llama 3 has a lot of different parameter versions available. Of course, if you have a Llama 3 70 billion parameter model and if you want to compare it with Phi 3, most of the reasoning and even math or most of the other tasks, you will probably see Llama 3 will do better. Same with if you were to compare with the Gemma different parameter models. So right now there are a lot of models for time series data. For example, Google itself has a model for time series data. I can point you to the link. So it's I'll point you to the, where is that? Point you to the paper for it. So where is the archive? I believe this is that one. I'll put it in the chat. So Google has own model called Times FM, Times Foundation model. Then Amazon Science has its own model called Chronos, and I think CMU came up with also another model with time series. But you will see a lot of people coming up with very specific foundation models for time series. So if you want to do time series forecasting, I think going for one of these models will be better bet. You can also use the existing models. For example, the Amazon Sciences Chronos model is actually based on Google's T5 model, and they have modified it to work on time series data. So those are T5 flat model. So those are also some of the things you can look forward. But yes, there are already models available for those, and I'll put them in the chat. So the data sources into GMRGK environment, there are a lot of different ways. You can literally connect with BigQuery to do that. I mean, if you have data in BigQuery, you can, of course, connect with Google Bucket Storage or GS storage directly to get your data. You can also connect with any of the existing connectors which has connections with GKE to do that.
All right, great. Well, thank you so much for the presentations, and I will, because of the time constraint, we're going to have, later on we have the workshop sessions. So we're going to stop the tech talk sessions, the Q&As. The good news, actually, later on, Ramib are going to lead the workshop. So if you have more questions, I see actually you have a lot of questions in the comments, and you actually have the plenty of time to ask questions on the workshop and also on the tech talk. So with that, we concluded today's tech talk sessions today, and we're going to take a 5 minutes break since we have quite a lot of content tech talks coming in the morning. So we're going to take a 5 minutes break, and then we will go into the workshop.
Thank you, Bill. And you're all, of course, very much welcome to email your questions or connect with me in social media. I'm not much active in X anymore, but Threads, Mastodon, Blue Sky, or any of the other 1,000 parts I'm available.
All right, welcome back. Let's get started on the workshop sessions. I personally very excited about the hands-on workshop because here you can jump right into the code and follow the steps. I see many of them actually already got early started. That's great. So for this workshop, what we're going to do is we're going to develop an app with Gemini AI and also the Vertex. And we're going to build more using the writing code and build applications called the Gemini API, and also deployed run your applications on the cloud run. So it's a great way to learn. Before get started, the two things very important to do. The first one is make sure you join the Slack and or the Discord. Either way is fine, and the link is in your emails and also on the I post on the YouTube comments. Make sure you join the Slack. We're going to do the live support over there, ask questions. And actually, a lot of questions already answered over there. Some of the instructions, step by step, everything is over there. So make sure you join the Slack or the Discord. And to get started on the Code Lab, the Code Lab actually running on the Cloud Skill Boost, Google training website. This one is actually using the real the Google Cloud platform, and they have a time bounded. I think this lab is for 1 hour 30 minutes. You will when you're running the lab, you actually connect with the Google Cloud platform. So the way they are running this one is many of the labs they are you actually need to pay to run those labs. For today, since we're running the events, we have that credit to use you can run those labs for free. The first step to run this lab is to get a credit. Otherwise, you probably have to pay if you want to pay with your credit card for the credit. But here we have that link. You can use it to get a free credit, and you can run the lab. So the way to get the credit is again the steps is in the Slack. So you need to follow that steps exactly steps. You will get the credit. I think we have the 10 credit to run the lab should be sufficient. Sometimes if you follow the steps, you're still not showing the credit, you can either redo the steps. You can log out and log back in, and the credit will show up. Once you have the credit, you can start to run the lab. Remember, once you start the lab, the timing will start counting, and you cannot pause the lab. It have 1 hour and 30 minutes. You have to either finish the lab or timeout. You cannot pause it. However, since we have more credit, you can run it again later on. And also with the credit later on, you can I think you have additional credit. If you see other code labs you are interested, you can try it out, you can run it, you can learn it at home. But you have to get the credit today. The link is in the emails or in the instructions. That link is going to expire I think by end of today. So you have to do it. This is the first step today to get a credit, and then you can do the lab today or later. So if you already have the credit, you're ready to go, feel free to have a sum up either in the YouTube or in the Slack. Just let us know you are good to go, or you're already in the process. That's totally fine. Hey, Ramita, you can get started on the workshop if you want. And meanwhile, I will helping those attendees have, if they have questions, I will answer them. But you can get started. Go ahead.
Okay. So let me try to share my screen. Okay, so this is the Google Cloud skill boost we are going to work with. Develop an app with the Vertex AI Gemini Pro. This is free for everybody who is going to use it today. So what we will do is that we are going to use the 1.0 Pro model and also the 1.0 Pro Vision model, and we will go through a little bit difference of like what this compared to my previous example was, what's the difference here. But for the people who are joining now only for the lab, we'll first go with this. So first, what everybody will do is that press the start lab button. Once I press it, it starts something like this. It starts a countdown timer, which looks scary, but 1 hour 30 minutes, it's enough time. Then it produces me some other things. This is a cloud username, this cloud password, project ID. There is no point copying mine because you all will get your own. We will use this specific username, password, and project ID for our work. Do not use your own to do that. So what we do is that we press this button, open Google Cloud Console. That brings me to a login page. Let me copy the link, paste it, and share that tab instead. Wait. Present, share screen, entire screen, share. Okay, so this is the one. If you still remember correctly, this was our Google Cloud username that was generated in the last page. I press next with it, and this is the password we got from the same page. We press with it, and we log in. Be very careful not to log in with your own username password, then otherwise it will be built with your own GCP. These are generated on the go, one-time usage for you so that you can do the lab today. So once I press I understand, this takes me in here. And I agree to terms and condition. This is my country. This is the user. I agree and continue. Now, this is my Google Cloud Console. I have access to all these. This is the project info, quick labs, the project number, the project ID, and everything. If you see here, this is the project. So we know we are in the right project. So we are not going to be built from something weird. And this is a student. This is the one we got created. If you see, the account is managed by Quick Labs, which is Google. So yeah. Now, what are our objective? So we will develop a Python application using the Streamlit framework. So you can follow along with me using the Google Cloud Skill Boost webpage you had opened before. So what we will do today is develop a Python app using Streamlit framework, install Vertex AI to work with this, develop a code which interacts with the 1.0 model and also the 1.0 vision model, and then containerize this whole application, deploy it, and test it on Cloud Run. If you have any questions, you can start putting them in and I will try to answer it. Okay, once we are in this stage, once you have logged in, if you follow the instructions, we need to activate the Cloud Shell. So Cloud Shell is a like virtual machine which we need to activate, which is this button. Let me make it a little bit bigger. Okay, so this button, this is activate Cloud Shell, and a bit more bigger. Yeah, so I press this, and I don't need this. So I get something like this: manage your infrastructure development, etc., etc. Cloud Shell is free for all users. I continue with it. It's provisioning my Cloud Shell machine. Got it. Okay, so this is the Cloud Shell. This is essentially accessing the VM we have been assigned. So first we need to see all the active account names to again make sure we're in the right place. So I do gcloud auth list. You can see the same command in your Google Cloud Skill Boost instructions. Once I press this, I need to authorize Cloud Shell, and I get the correct account listed, and we can see if this is the same one as not. So I can say this is the same one and we're in the right one. So we also need to see we're in the right project. So again, gcloud config list project will show me the projects we are. So we are in the right project, the quick lab CCP, this one, which you can kind of see from here as well. So we are in the right one. Now we need to configure our environment and the project. To do that, we set the project ID and environment variables in Cloud Shell. You don't have to manually do that. Your Cloud Skill Boost page will already show this information. I am copying from my information and just pasting it here. So this is what my information should automatically populate. And when I press enter, it gets populated that your active configuration is Cloud Shell, region West 1, and Quick Labs. So very good. Now we need to enable a couple of APIs which we can do manually. For example, the AI Platform API and Cloud Run API, but we can also use it with this nifty G-Cloud service. So let's see what we are enabling. We're enabling the Cloud Build API, the Cloud Functions API, which we will need, the Cloud Run, logging, so that we actually know what is going wrong, the storage app component to store our data, and of course the generative AI part. Once I press enter, actually I can probably maximize it. And maybe I can make it bigger. Oh, no, this is okay. So we can see it finished successfully. So we have it enabled. Once it is done, you can, so let me just drag this different window here. So all I have been doing till now is literally copy pasting commands from here. This is the command for enabling the region. This is the command for enabling the cloud services. Once you are also done with it, you should press check my progress. This will automatically check that if you have done this correctly, you will have something like this, the green tick like me, and the assessment should be completed. Now we set up the application environment. So you should have this window open. I have this window open, and you can just follow along with me. So here, we need to confirm the Cloud Shell is authorized. So we just do something like Cloud Shell, gcloud auth list. So it will check the authorization list, and we'll see that, yes, okay, we have that. And if it asks you to authorize the Cloud Shell, you should have a like small pop-up window like I had initially to authorize the Cloud Shell. Now let's make our first directory. So we can make a directory like Gemini app and press it, and the directory should be there. If I do a ls, I can see that Gemini app is there. Now we need to log into that directory. So I am in that directory right now. Now we are gonna use Python's virtual environment to create a VM environment for our application, so that any changes we do, any applications, any pip libraries we install is part of that specific environment and not affecting our whole installation. This is very useful if you are creating multiple applications with different dependencies, and overall recommended practice. So what I do is that I run this command, which essentially creates a virtual environment named Gemini Streamlit, and press it. It will provision a couple of things. And here we are. Once it's done, we need to activate this environment. How we do that is literally run it that source Gemini did. Inside that, activate this, and now it's activated. How do we know? You will see this appended before your session. So now we know we are in a virtual environment. Now we need to install dependencies in this application. So for us, the dependencies are AI platform and cloud logging and Streamlit. To do that, we will create requirement.txt, and from that requirement.txt, we will actually just run it. So you can also do something like vim requirement.txt, or if you just want to follow the collab, then the cloud skill boost, then you just paste it. What it does is that it uses the cat command to create a txt file requirement.txt, and inside that you have these things. So once I run it, I see there's a requirement.txt, and if you want to see what's inside it, you see these are the things: Streamlit, Google Cloud, AI Platform, Google Cloud Login. If you want to have any more application libraries installed, you can just add something here and it will work. So we go out, our requirement.txt is working perfectly. Now we need to install these dependencies. So what this command does is that it tells pip, which is Python's package manager, to install anything that's in requirement.txt. Once we run it, so I see one question about points. The points are, so you will start with 0 points. So you will start with 0 points. The more you start going with, the more you start finishing up each of the requirements, you will start getting, oh, I don't have control over my thumbnail. Maybe, yeah, I cannot control my thumbnail. That's StreamYard, I think. Yes, that's better. Okay, now you can see everything. Okay, once you've done it, now we start creating the application. So how kind of the code lab goes through creating the application is literally using the cat command to build the whole thing. You can also do that, of course, which I just did, but you can also actually just copy paste and do that. But let's see what we did just right now. So this is the app.py, which got created using our cat command, and let's go through it step by step. So we import a couple of libraries. We import OS, Streamlit, and a couple of other things, including Vertex AI and the cloud logging. We configure the logging to specifically only throw us the info, not anything else. And we have the project environment set with project ID and region. Remember, these we have configured beforehand. Now we load the models. We load the Gemini Pro and the Gemini Pro Vision model, and this is going to be the header of the Streamlit application, just Vertex AI Gemini API. And these are kind of the tabs. We'll have the story, marketing campaign, image playground, video playground. You can change any of these if you want. It will still show. So I can do something like, and it still should work. So once we see, okay, once we have seen what we have done, now we develop the story. So So as you just saw, we have a story tab. So we have something to have inside the story tab to render something in the story tab. So we're going to create something called app underscore tab one, and we'll have things under that. So if you follow skill boost, it's gonna ask you to use this cat command to have everything in one go, and it will create it for you. So now if we see, let's clear the screen. If you see, this is what we just created. So this is the generation prompt. We have a character name, we have a character type. The character name is Mittens, type is cat. We have a persona of that character, what the character personifies. Mitten is a very friendly cat. Then there's a location, length of the story, how long we or short we want it to be, and then certain things. So how it should be, sci-fi, fantasy, thriller. Then we have this creativity control. So some of you who are already playing with LLMs then know what temperature is. I'll still explain very shortly. So what temperature is that it essentially is how creative your AI will be. So when I say creative, means that how each time you run it, how different, how wild its the probability distribution of the words will be. If you have it more, the temperature more, the more the varied distribution will be. The less distribution will be. In short, if you have it very near to zero, you can put it zero. Technically, it's never zero inside in LLM. But if you put it very near to zero, every time you put the same prompt, should get you the same answer. But anyway, let's go through the code. We have the length of the story, the prompt, the temperature, and everything. Okay, we are happy with it. We go out. And we also need to develop the responses, so that we do using the next command, which gives us the response utils.py. Let's also take a peek at that. This is what it does. So we import certain specific points from Vertex AI generative AI model. So we have content, generation, configuration, model, image, harm category, and everything. I will not go through all of them, but a very specific part of them, which we have not discussed in either our talk or here. What's that harm category? What's that harm block threshold? So remember, in my talk and the other talks we have discussed till now, there was always part of that responsible AI. So that's where the inbuilt guardrails and inbuilt harm detection comes in for Gemini. So you have these categories, these thresholds, where the model can itself review itself and see what the responses is, how much harmful, how much abusive it can be. There are different categories of harm. So you can actually tell that, okay, this category I want, you can tolerate this much, but don't uh, tolerate anything, block all of them. Or you can also have to, okay, block none. You will still get a wording that, okay, this is what I'm getting output, and you still cannot make it produce like harassed content. But these are extra guardrails you can put in. So you can see in the safety, we don't have any blocks right now available in the response. And this is essentially all the configurations we have. There are a lot of other configurations you can do, but this file will provide that. Once we are done with it, let's try to actually run the application. Let's clear the screen and let's run it. So what we do is that we run a streamlit command, which tries to run this in our own machine. So which is for us is a cloud VM. So it will run in VM's own local host in port 8080. This application, which will in the backend connects with all the 3 Python files we have. So once I run it, just run, and you can now view a streamlit application in your browser. Don't open localhost 8080 because you will see nothing. So because see, if I try to open it, it opens this link. So this is not localhost 8080. This is a very different link. So don't try to open localhost 8080 because that's going to be your computer's localhost, not Cloud VMs. So if you want to see Cloud VM, you can either do what I just did, press on this, and it will open this whole link for you. Or the correct way probably is you can see this here, the web preview. Once you click the web preview, you have an option like which port you want to see. So we have defined port as server 8080, so this works fine for us. But if you don't want, you can change the port. But anyway, we press this, and this is the application. So this is kind of, you can, I mean, both, you can use both, but this is the recommended way to do that. You will also see this way in the Cloud Skill Boost, not the way I just did. Now let's test our application. So enter the character name. These are the things we already have in our Python application. We can change them. So let's okay. So I think this works fine for us. We can live in Andromeda Galaxy. I wanted to be creative. Of course, sci-fi. Generate our story. And let's make it bigger. So as you can see, it has chapter by chapter story of everything. Now, if you are in this stage, you can just press the check my progress button in the skill boost, and it should check your, so what I just did, check my progress button, I just click, and the assessment is completed. So it will know if you have been able to create and play with the story. Once that's done, we can start playing with other things. You will see this one has other parts like marketing campaign, image playground, video playground. None of these is right now present. So let's start creating them. Let's close one of them. Okay, we are back. So this is where we can see the output of the server. So this is a local host. This is the output it just did. And let me just stop this. And okay, so we are stopping our server and we are back. Now, if this is actually not running right now, if I refresh it, it will go away. But this is our second tab, right? So second tab, third tab, fourth tab. So for the second tab, we need to create an app tab 2, which if you copy paste again, this is what you will get. And I press enter, I have something called app underscore tab 2. So again, we see what's under that. No. Okay. So here what we have. So we have text friendly model, generate your marketing campaign. And these are the specific prompts we already have inside the campaign. So it will use these as a boilerplate. We have the temperature, output tokens defined. So this should work. Now we also need to modify our entry point. So which is the initial app.py. So here, so we have the render story tab, right? So we also need to have another part where it will know that it is going to have the other part, from tab 2, what it should have. So we just add this, and do the same thing again. Here we see what it added was just literally after what we had, we just add these two lines from app tab to import render marketing campaign tab, and with tab 2 just enter that same model. Once we have it, we can run the same command, which is stream it run. It's running again. Let's see. Of course, because this was the previous one, and it's running in the same one. Okay. Now, if we go to marketing cap, this is now working. Previously, it was blank. Now we have a generated marketing campaign using Gemini Post. So exactly what we have put in. Okay, we need an interesting product name. So okay, so this is electronics, target range 1825 is fine. Rural. Of course, we need sales. Humorous. Yeah, we don't have budget anyway. So let's create a campaign. Okay, so it's a revolutionary new line of portable solar powered electronic design. So you'll see it created a target audience, campaign objective, product, campaign channel, most of the things you will probably need. So these are the prompts which we had defined in our application. This is what it's gonna use. This is exactly what it's using inside with our input to kind of to create the campaign. So use relevant KPI to measure performance, describe how we'll track the success, specify primary and secondary goal of the campaign. So it tries to use these prompts to kind of generate this marketing campaign. Now let's go back to our skill post. Let's check my progress. Yep. And we have more points here. So we check our progress estimates complete. Now let's start playing with the image. Again, I go back, stop it, and start playing with tab 3. So we need tab 3 for this. So again, this should create a tab 3 for me. Clear. Yes. Okay. So app underscore tab 3. So which is this? So here you will see, let's do something interesting. We just want to see whatever we change here works or not. So these are where it's getting the images. These are already part of the Google Cloud bucket. So you take those images, we have these, and we'll work based on that. So, okay, I save this file. And we also need to have our responses added to it. So to do that, we create the responses utils file, which got created here. So what happened is that it literally will add responses after that. So let's see what it added. So previously we had only this definition, Gemini Pro text response. This is the text, the harm category and everything. Now we have something called Gemini get Gemini Pro vision responses. So you will see specific temperature set, maximum token, and defined how the vision will work. So we go out of it. We again need to modify our app entrance. So we open it. So up to here we had from app tab 2 render this. So we now need to add the same thing for tab 3. So this time I'm just manually adding it. So from app tab 3, image render image playground tab. And we need to save this file, which I did here. Once this is done, we again try to do the same thing. Okay, so we try to run the server and it should run. Again, refresh this page. Okay, if we go to image background, here are the things we have: the furniture recommendation, open instruction, ER diagram, math reasoning, they're not there. Furniture recommendation is here. You see, the changes we did is here. Good thing, the whole thing is imaginary. There is nothing called Gemma, and that's in future. So this is the image of living room. These are the images we had in our code. And let's see if we want to, if we generate recommendation. That should not have happened. Okay, let me close this and run it again. Okay. Okay. So now it's running. If you also face something similar, you will also see there are a couple of errors you might face. One is obviously the one I just got, but if you see Google Cloud Skill Boost page, you will see it tells you about another error, which is if you this is error failed precondition. That literally means that all these we have these files, these buckets, these are being provisioned. It's not ready yet. The error I got is different. That's a permission error. But if you have it, just stop your application, run it again, and it will auto provision. You should not have a problem with that. So you see, we got the responses. This is chair, not suitable for the room, is suitable for the room, not suitable, is suitable. Let's see if that's true. This is a room, a white background, and all these. These are the 3 chairs we got. Not suitable, bar stool does not match the other furniture. Is it true? Yes, this is the bar stool. It does not match other furniture. This one, I would say this matches. So yes, this is soft upholstery, matches other furniture of the room. 3 is again, yeah, probably doesn't match. Yes, not suitable for the room, doesn't match. Is suitable for the room because of this, and yes. So this does work. So let us go back to our cloud skill post. It's developed, check my progress, and we have earned 10 more points. Now we analyze our image layout. So this was the output we were getting. Chair. This is all the output we just got. So let me stop it again. Now we again add more things to our tab 3 because we want the open instruction in that tab. So we just add it. It should be added. And it also passes open like an image to the open instruction tab. So let's run the server again. Refresh my page. So if we go to image playground, now we have the open instruction. This is image of an open panel. The prompt is, how can I reset the clock on this application? So this is a clock which is visible. I want to know how it can be reset. Let's see what it does. So it can understand it and it will give me instructions step by step. So look at the clock button on the control panel. So look at it on the right side of the panel below the kitchen timer button. So it tells me exactly where to look. Press and hold the clock button for 3 seconds. Clock will begin to flash. Use the number button to enter the correct number. Press clock button again to save the new time. So this is the instruction we got, and we check our progress. This is completed. Yes, you can use other images. You can use any other image you want. So this is just like to show you how you can work with it. After this code lab is done, you can just do it in your own machine. Just point it towards the API. Now we'll analyze ER diagrams and play with that. To do that, I can stop it. Now we need to pass it the ER diagram images, which we again add to our tab 3 by this. And again, we run the server, we refresh the page, image background, ER diagrams. Now this added the diagram, math reasoning should be empty. Okay, so we need to document what's happening here. So for the prompt for it, say document the entities and relationship in this in ER diagram, then we have the input image. Once we run it, so this diagram contains the following entities: category, vendor, item, sales, convenience store, county store. Is that true? We can see category, vendor name, item, convenience store, store. Okay, and the relationship between the entities are category can have many items, vendor can have many items. So we see it can understand what's in the text, but that's optical character recognition. What's not OCR is that it can understand the relationship between them based on the diagram, based on why it's being pointed and what's the relationship between them. That's the more interesting and more, I would say, impressive part. So we see it can analyze your diagram. It's still, we don't know about math. So let's see what we can do about that. So let's add the math reasoning to the same app 3. I added just some of the math images, like just written, handwritten things. And then if we want to play with it, remember all of this we are showing, you can do even more easily using a Google Colab if you want to just play with it. So image background, and we go to math reasoning. So this is an image we passed, the most beautiful equation, and we have an equation. So these are kind of the questions we are asking. Extract the formula. What is the symbol right before pi? What is this? Is this a famous formula? Does it have a name? So this is the format prompt we are using. Follow the instructions. Surround the expression with dollar. Use a table with row. So we specify a very specific format how to do that. So these are the instructions, and let's run it. Okay, so this is the formula we have extracted. Okay, it's mostly correct. This is supposed to be the not equal to sign. What is the simple let be pi? Is I? It's an imaginary unit, which is a mathematical concept. Looks right to me. Is this famous formula? It's a famous formula. It's not Euler's identity, which is also correct. So it can recognize what's being said, what's there. Okay, so now we want to do and see and do the same thing with video. Before that, just follow along with me, check our progress. Okay, we are on right track. Then we generate the video playground. To do that, again, we first stop it and add the information on app 3. Okay, and here, if you see, we have app 3. So we now also need to add it to the entry point. This app, app tab 4 we just created, but we need to add this to your entry point. So this does not know what is in tab 4. So we shall do that. So I'm just gonna manually do that. You don't have to do it. You can just copy paste from the code lab. So we have app.4 and what to show in the 4. Okay, we save this file and time to test it again. So this was our command for testing the server and we run it. Okay, we refresh this page. Okay, and we go to video playground. Okay, now this has a video. These still are empty, but we have the description. The video is running. Now we want to generate a description of the video. So our prompt will be, what am I looking at? Where should I go to see it? What top 5 places like this? Let's see how it does with it. Let's go to this prompt. What am I looking at? I didn't ask where from this video was taken or anything like that, but it understood the context. The video is a drone shot of the harbor in Turkey. The town is built on cliffside overlooking Mediterranean Sea, etc., etc., etc. Let's verify it. Like they say, trust but verify. Let's see if we can find that image. We cannot, but it looks similar. Okay, this was probably that part. Okay, and then the town is built on a cliffside overlooking Mediterranean Sea, water is crystal clear, etc., etc., etc. The can be converting a to German airport, taking bus or taxi to gas. Other top places are these. Looks pretty good to me. Then let's go back here, stop it, and add other parts of the video. So we need to generate video tags. Imagine if you want to build an app where you have created, you are a content creator, you are creating your videos, don't want to think about video tags, you want to automatically generate. So what we do here is that we add things in that app.4 by this. So essentially what we just do is that pass it what is the video, provide 5 base tags. So we just added this, provide five base tags, and then we run it again, refresh. Okay, here we are. So video playground, now we have the video tags part. So this is a different video. Let's see what it does. It's a slow motion video. Somebody taking a picture. These are prompts. What is the video? What objects are in the video? What is the action in the video? Provide 5 base tags. Once we generate the video tag, okay, what is the question in the video? Man taking a picture with a table, picture of a table with a camera. There is a table, chair, vase, plant, candle, statue, and a camera. What is the action in the video? Man is taking a picture of the camera. Provide 5 base tags: photography, art, travel, nature, photographer. Looks reasonable to me. Now, what are the highlights if we want to have highlight of a video and also where it's taken? So let's go and add what we need for highlight. So in app.4, we are gonna add this. So we are we'll send it towards a video, and then we just add a single thing, which is what is the profession, what is the comment video used for, and what's exactly the highlight of this video. Once we do it, we run it. Video highlights. So let's look at the video. This is a train running. So why this video is important is that so you might have seen this video in Pixel's ad. This is showcasing a feature called Video Boost, which takes when you take a video with Pixel, and if you have this feature enabled, it will automatically use machine learning to do tonal mapping and have, I would say, a HDR mapped night video, which looks, trust me, awesome, at least in my phone. So this was the showcase video for that, and these are our prompts. What is the profession of the girl in video? I think she explained in the beginning. I'm a photographer in Tokyo. Which features of the phone are highlighted here? So these are not explicitly stated unless it's here. In low light, it activates night sight, etc. etc. Summarize the video in one paragraph and response it in a table. So let's run it. What is the profession? Photographer. What features the phone highlighted here? Night sight and video post. The video is about a photographer working street at night, testing on the features, nice, very impressed with the quality and videos that she's able to see, which is pretty good from what I can see. One very interesting thing is that you will see throughout this video there is something going written here. Person shown is real pixel owner, paid by Google for this video. Showcases a feature. There are other things written there. Coming to Pixel Pro only, request photo update, etc. These are not ingested, so the model actually knows what you are looking for. Okay, with that, we check our progress once again. We are right on track, and now we'll see if we can generate a video location for this. Let's go back here, stop it, and we again update the generation tab with this. So what we did is that we passed another new video, and what we said is that what is straight, what's nearest section. Let's run and see what the video is. We run it, we refresh. Go to video playground, video geolocation. That's a really rainy video. So you'll see it's raining a lot. Let's try to answer the question ourselves. Do you know which city is this? With what street is this? What intersection? So as humans, any of you can get that information from this video? If you can, I'll be happy to see it in the chat. So let's see. These are the prompts we have. Following questions. What is the video about? How do you know which city it is? What street? What nearest interaction? Let's go to the response. So a bus driving through a city in the street in rain, that we can get. By the street signs and buildings in the background, how do you know which city? Well, as a human, we should also do that, but I cannot read anything in the video. So what street it is? Wellington Street. What's the nearest intersection? Wellington Street and Bay Street. So that's the impressive part for me here, because it can do a optical character recognition to read the street address, which I, at least from this video quality, I cannot read. And then it uses its own information to say that what is the interaction near that. So that I would say pretty is impressive as a model. And we go back here, test our progress. And yes, we have done our progress. Now we need to deploy this app in Cloud Run. So we need to first specify, let's go back and stop it. So this was right now running from directly from Cloud Run. So as long as our VM is active, this is running. The moment I stopped it, there is no backend. This is not what is ideal. Also, this URL is not ideal for sharing to people. We want it to be active in a maybe permanent VM, which is costly, which we do not want, or we can have it in a cloud run, which is a serverless solution, which is much ideal for this. So let's make sure we're in the right directory. We are. So we're not gonna do anything with that. And let's verify our project and everything is correct. So yes, we are still in the quick lab Europe region. And then we set the variables correct for our service and artifact by this, and this is set. Now we create a Docker repository for this to run this app, to deploy this app rather. So not this. Okay. Yes, we have the service name. Now we need to have the G Cloud artifact repository. So create a repository based on that name and everything, and it will try to create one. So it's creating that request. It's waiting for the operation to complete. And it's created. Now we set up authentication for it. So authenticate our Docker instance. Okay, it has added the credential. Now we build our Docker file, which will be used to build this. So this is where just using cat to define our Docker file. What it essentially does is just tell that, okay, expose port 8080, copy our present directory, the server address is 00000, opens it to the whole internet, the Streamlit application endpoint, where it's starting from app.py, and before that, install all the requirements from requirements for the file. So our Docker file is created. We can actually see it. There is our Docker file. Now, to build the container image, we just run this command. So this we just pass it to create the image. Now it submits the command to build the image. It's creating the temporary archive. It's doing everything to run it. This will take some time. So until this is like keeps on happening, uh, everyone has been able to follow. Is there any question? So math, so I see a question, given the math demo was incorrect, after you train it more within that conversation, how do you save that training to do further inference? So there are a couple of ways to do it. First is that using any LLMs to kind of just do mathematical calculation probably is never going to be a good idea, because these are, imagine a prediction system. Math is not prediction. So what, if you want to have it to solve math, what you do, and Gemini supports it, is called something called tools and function calling. If you had attended my talk, the previous one, I had shared a GitHub repository which has at least like 6 different code notebooks where you explain what is function calling, how to work with it. So you can actually use those to specify and work with specific tools, including calculators, to kind of do your actual math, and then ask LLM to do the reasoning. So that's one part to get a better answer. But if you're asking more about like, okay, I am giving input that, okay, this is wrong, do this, do this, do this, and how to have that conversation memory part of that. So there are, based on what LLM you're using, there are ways to achieve that. So if you are using Gemini 1.0 Pro model and you are using the mode multi-turn chat, then you can actually have that memory and it will remember that memory. If you're not using multi-turn chat and just passing it as each command, then you have to use frameworks like Llama Index, LangChain to kind of build your own agent memory. Meanwhile, we see our Docker image is getting pushed. Oh, so I see one question. What was the solution to the OAuth problem in task 6 again? I just stopped my Streamit instance in the Cloud Bash and I just restarted it again. And that worked for me. Okay, so it's finally done. We have our Docker instance created. Now let's deploy it in Cloud Run. So what we do here is that to do a gcloud run deploy service name, and we pass our whole Docker to that. Once we do it, the service is deployed and a URL should be generated. So it's deploying the service, routing the traffic, and it's creating a proper identity policy for the app to work. Do we have any more questions? So function calling does not save the context history. Function calling is literally asking the LLM to do a stuff, like do something in a very specific way. We don't like, this is kind of out of scope for today's lab, but in very short, imagine you want your LLM to output some information in a JSON format. So you can give it an example that, okay, this is how my JSON format looks like, output something in this format, and it will try to do that. Remember the try part. In production environment, you don't depend on tries. You have to be sure that it's the correct JSON format. That's where function calling comes in. You define functions just like normal Python functions. In the function, you get certain things, and you have the Python code do something. from the LLM, you ask very specific things, and the LLM knows if some very specific things are asked, it will go and run that Python function and work on that output. So that's essentially in a very high level what function calling is. For our use case, we can have a function which literally does mathematical calculations. So a Python function to do all the mathematical functions you might want it to, use the LLM to understand what the equation is, but to actually calculate it, call that function, get the output, pass it on to you. You get correct response every time. And in production, that's pretty important. So we see it has been deployed. We have a service URL ready for us. Let's try that. And it's running. So this is not dependent on this cloud machine anymore. You see there is no server running anyway. Now everything is here. It's not this. And let's see if it works. Generate my story. All the things are here. Now, you still need to add a Vertex API access to it because this is a code lab. This will be temporary for it. But this is how it will work. So once you have done with it, these are all the things you have. This is how you deploy this whole application. So once you have reached this stage, you are in this check your progress button. I can share this again. And if you have checked your progress, you will see everything is done. All the things, everything is complete, and you can end your lab. Now, before you end your lab, if you want to actually see how this application is working, then let's see this cloud editor is here, and this is our application. Let's give it some moment to run. Okay, then the video was more interesting. So let's go here. The prompts are here. Try to generate a response. Now this is running, trying to generate location information. Okay, we have the location information ready. We go back, see, yeah, this is not running. This is running directly running from here. If we go back here, marketing campaign, improve brand sentiment, a little more budget, serious, share campaign. Okay, it works reasonably well. This is more serious than the last time and have a lot of things. Okay, so we have completed, we have managed to build an streaming application that writes a story for you, does marketing campaign, understands images and suggests good things for your room, does video playground, has math reasoning, open instruction, and everything you might want to play with. So that was our code lab. That concludes what we do today. Once you are in this stage, congratulations, you have deployed, you have done all these within 1 hour. And if you are done with it, and so you don't have to do it with me, so you can do it in your own pace. Once you click the end lab button, it will ask, and if I press end lab, I'm pretty satisfied. Congratulations, thanks for reviewing this lab. And we go to next. These are the resources you get from this lab. So you earned 100 points for completing the introductory lab. So that was all we had for today. I will also stop this, and okay, so here we see all the APIs, all the requests we did, and everything. You see, even with this, it's not that much. If we go to the API overview, these are the different services we used. If you see, we most used Vertex AI, which is because we were sending requests. We did the logging quite a bit because we were logging everything. These are all the things we used. With that, I think we are at the end of the session. So do you have any questions or any other questions for me?
All right, thank you so much. That's tons of informations, and I hope not sure how the attendees following through all of the steps, and I think some of the questions, some errors, and in the Slack. What we can do is we're going to end the live stream very soon. But all of the information is in the Slack. So maybe for the uh, uh, for speakers, are you like in the Slack? I mean, if you like Slack,
Yeah.
maybe quickly go through some of them to see if you want to answer it right now, or you or if the attendees have other questions, easy to answer, or quickly, we can answer it right now. But we can have like more questions later on in the Slack.
Let me restart my Slack because somehow that space is not opening.
And meanwhile, for the folks on
Okay.
the bear with us for the whole events, and we thank you so much. Stay with us for the until the end. I hope you have a good learnings today with the tech talks and the workshops. Again, for the workshops, if you already have the credit, the 9 credit at the very beginning, you feel free to run this lab or the other lab as many times as you want. You can rerun it and retry. I know the first time you have a lot of questions. You probably cannot finish it in the time, but you can run it again and again. For those one you haven't got the credit yet, you have to using the instructions to get the credit today, because that link to get a credit will expire today. So you have to using that link, follow the instructions. Again, the instructions is in the Slack channel. Just follow that one, and you will get a credit. Once you get a credit today, that credit is going to expire in the next 6 months. So you can run this lab again, or if you are interested in other labs, there are a lot of very good labs on the Gemini models and also Vertex AI code labs. So you feel free to run any of them. Rabiba, do you have any questions you want to answer in the live stream here, or we can just we can
Let
answer
me. I can actually answer later in Slack, but let me just quickly go through Slack and see if there is something other than the debugging parts. So yeah, so I see somebody, your current actor does not have valid credential. Look at the previous step in the instructions, there are 2 steps where it like goes through that. Okay, validating the credential. Does the shell have limited capacity to type the commands? Should not be. I was able to copy paste everything. Everything can be done on AI Studio. Yes, and not only everything, a lot more can be done in AI Studio. The point of this was to actually how to do that in Streamit or in Python and actually deploy it as a Cloud Run application so that you can actually not only play with it, but deploy applications like that. So, yeah. When the timer runs out, will we be unable to access what we just did today? For this immediate part, yes, because so it will stop that temporary instance, but you can run it again as long as you have the credit and create it again. If the session lab will be recorded, I think Bill knows that.
Yes, it is recorded.
Yeah, so when I open a file, okay, so apologies, I created Vim instances immediately without actually going through what Vim is. Vim is a text editor, which is a little bit not intuitive, I would say. So if you are following me, when you open Vim, open a file using Vim, what you do is that Vim space the file name, it opens the file, but it's in read-only mode. If you want to edit something, press I on your keyboard, it will get into insert mode. There you can add or remove things. If you want to go out of it, press escape. It takes you out of insert mode. And then you have to press this, which will take you to quit. So it's just Q, it will take you to quit. So that's, if you are stuck in Vim, just do that and it will take you out of Vim. So the model is giving wrong instruction for open panel, the clock panel is on the right side, kitchen timer is not, etc., etc. So look, I haven't actually opened the image on my side, but try it multiple times. See if always it's giving you the wrong answer. So it might be one time it's hallucinating and giving you the wrong answer. Other times it is not able to actually OCR the page, and since it has no information, it's just hallucinating. So these are like, this was a very basic example. You can have guardrails against hallucination where it cannot read. It will just tell you, I do not know, or I cannot answer, instead of just coming up with random things. How to enable billing, cloud, like the steps in this instructions will already enable, you don't have to enable billing by yourself. In the very first 3 steps, we enabled all the API services we needed for this code lab. So the app.py, you can literally follow the instructions and just copy paste it in a code pad or somewhere, or open the app.py in Vim, just copy it, or from your Cloud Shell, like SSH into another machine you control and just copy that file. So you can go with whatever you want. I think, okay, yeah, I think I went through a couple of the initial ones.
Oh, sorry. Are you done?
Yeah, I think I went through.
Sorry.
Yeah.
Okay, great. Oh, well, all right. I think, that's conclude our today's live sessions. Well, again, thanks, Ranbir, for the tech talks before, for the lead of the workshop. Really appreciate it. And thanks everyone for joining us today. And I hope you learned some things. And again, with the credit, please, to keep trying. Sometimes if we get some errors, just rerun the lab and retry the steps. Sometimes it just works. And again, with the credit, you can run these labs again, and also other labs you are interested. So keep learning. We will share the recording videos and the slides, and you will get the notifications when it's ready. Yeah, that's. I hope to see you again in next events. By the way, we also run these same events in other city, in many cities around the world in person. The next one actually coming up in Seattle on this Saturday, next Saturday. So if you're in Seattle, you can join in person. And I think the week after next week, we also in Austin, Atlanta, and also in San Diego, a few other places. So if we're in those cities, and feel free to join our in person, and we hope to see you again in the future events. All right, with that, I will conclude today's events. Thank you so much.